Alright, sorry about that last video. I ran out of time. I didn't realize, but we were multiplying these two matrices. We were finding A, B. We did the dot products, and let me grab my pen. Alright, we did row 1 dotted with column 1. It's right here. Then we did row 2 dotted with column 1. So, if we add all those up, if you take 18 plus a negative 5 plus a negative 20, all that comes out to be negative 7. Then if you take negative 12 plus 4, you get negative 8 plus 0 is a negative 8. Alright, so that is the matrix AB. AB is 2 by 1, and that's what we thought it would be. Alright, yeah, they gave us the A and they gave us the B, so we had to find AB doing those dot products. Let's try one more. We're actually going to have a different A and a different B, and we're going to find both AB and we're going to find BA. Alright, here's the last example. I need some space for this. If you notice that here, yeah, we have to find AB and BA. And in general, you know, they're not going to be the same matrix. So obviously these are going to be different sizes. So let's go ahead and do these rows. Here's row 1. This is row 2. Just over the top of it. And this is row 3. This is column 1, column 2, column 3. Alright, so I'm going to put AB, I'll put it down below. Alright, first of all, let's get the size of matrix A. A is a 3 by 1. Matrix B is a 1 by 3. So yes, you can multiply them, and then AB is going to be a 3 by 3. Alright. It's going to be a big 3 by 3. Remember, what we're doing is taking the dot product, so I need row 1 dotted with column 1. That's just 6 times 0, which is going to be 0. Right, row 1 dotted with column 2, 6 times 7, 42. Row 1 dotted with column 3 is 6 times negative 1, which is negative 6. Alright, let's do row 2. Row 2 dotted with column 1, 0. Row 2, column 2, negative 35. Row 2, column 3, positive 5. And in this last row, row 3, column 1, 0. Row 3, column 2, negative 14. And negative 2 times negative 1 is a positive 2. Alright, that AB was pretty easy. That was a big 3 by 3. That's what we expected. So now watch when we flip this around. If we're going to find BA, our B was 1 by 3. Our A was 3 by 1. So yeah, you can multiply them. And then BA is going to be 1 by 1. It's going to be a 1 by 1 matrix. Alright, so I'm going to put B here. Let me erase these columns, because B is coming first. And I'm going to put A, rewrite it on this side. Alright, so now I have to take the row of B dotted with the column of A. So matrix BA is going to look like this. Remember, it's a 1 by 1. Alright, that's going to be row 1 of column B, excuse me, row 1 of matrix B dotted with column 1 of matrix A. So 0 times 6 is going to be 0. 7 times negative 5. We're going to add a negative 35, and then negative 1 times 2 is going to be 2, like that. Remember, this is a 1 by 1, that's one big dot product. So when I add all that together, you get a negative 33. This is the matrix BA, which is a 1 by 1. Exactly what we thought. So obviously, those two are not equal. AB is a big 3 by 3. BA is 1 by 1. So we'll put this note way down at the bottom. This is the very end of section 2.5 and multiplying these matrices. Given matrix A and matrix B, the matrix AB in general is not equal to the matrix BA. Alright, if BA even exists. Just because you can multiply A times B doesn't mean you can multiply B times A. Right, so just keep that in mind as you're going through these problems. Right, that's the end of 2.5.